the thing that makes this problem, guys.
You're really loud.
Yeah, the thing that makes this problem different than the last one, guys, is that the two circles we're looking at are tangent circles, guys. So there's an actual point right here of where the two circles touch. Now, there are two basic strategies I keep reminding you guys of. I'm going to do it on every problem. Always start off by drawing in the right angle for the tangent and the radius, so you don't forget it's there. Second rule is to label all the radii. Mark them with their lengths. Because if this length here is 5, then this length is 5. If this length is 3,
What's the question?
that length is 3. The question was, what's this guy up here?
Oh.
But if I know these two lengths are 5 and 3 respectively, then I can get you the whole length of this whole segment right here. That would be 8.
Oh, but x doesn't equal 8.
Nope, x is not 8. However, I can take this line here and I'm going to just move it down so it's right here. Using that trick.
Wait, did you move x down?
I moved x down. I'm just going to basically slide it down the rails of that 3 and 5 radius until it bumps onto the center of the smaller circle. So now this length is x, which means I'm working with this right triangle.
Oh, I drew my circle wrong.
I've got x here, 8 here, and then this length over here, 2. Because that's 5 minus 3. The radius is 5 units, this length. I slid it down 3 units, so that leaves 2. Now it's a Pythagorean theorem problem. If I've said it once, I've said it at least 4 times in the last month. Most of this chapter is tied to Pythagorean theorem problems. Valeria, what's on your mind?
So why isn't it the other way? Like, why isn't the triangle that you made the other way around?
The other way around?
Like, from on the other side.
Like why did I not do it that way?
Yeah. Well, not like that way, but still.
Um,
X is 7.5. Is it because 3 is shorter than 5?
yeah.
You have to you're small.
Yeah. And the thing too is if I were to take the 8 and I were to shift it up, I wouldn't quite be creating the same. I could actually. I could do that. But I would be shifting it up past this point. It would actually be hitting right here. And be going to this point here. And my right triangle then would be 8 on this side, x up here, and then this length would be 2. We don't usually do that because it's a lot harder to visualize, where it's a lot easier to visualize sliding the bar horizontally down and keeping a rectangle consistent than moving the bottom piece up and creating a parallelogram.
I didn't put the bottom piece up. I just like, I don't know. I just took from the other side.
Okay.
The corner.
Okay.
What are we doing after this? I really have to go to the bathroom, but.
Well, let's finish this one up first, and then we'll do a little transition.
I don't want to miss anything.
You'll be fine. 2 squared plus x squared is equal to 8 squared. And then it's a matter of just doing some basic Pythagorean theorem stuff. So x squared is 60. Now, in the name of review, and this is kind of important, again, you guys did this last year, but it's worth reviewing. The square root is 60. I'm going to write it up here so I have some more room to work with. Simplify radical form. What numbers that are perfect squares divide into 60? 4 does. The 16? No, I don't think it does. 16 would land me at 64. So 4 does, though. So I can factor this as 4 times 15. Square root of 4 is 2. So 2 square roots of 15. And that actually, guys, is still something you don't want to lose. Because whether or not you believe it's important to be able to handle radicals, they are something that are considered an expected high school skill. So if we can't convince... Wait, that's not right. 15, take the square root, times 2. Okay, that's right. 7.74. I usually round it to the 100th, and I always round to the evens if there's a 5. And that's something that you'll pick up when you do more science classes. Bye, Scott.